All right, here's some supplemental videos that I'm going to do on determinant of a 2 by 2 and inverse of a 2 by 2. So this first page of notes, and I'll post a blank copy of the notes if you want to follow along and print them out, follow along, and do some notes on your own. So when you do the check for understanding, you can use some notes that you take. Same thing with the videos that are posted in the lesson from the county. They have capture sheets that you can download and take some notes on. So when you do the check for understanding, you can refer to your notes. So a square identity with ones on the diagonal from upper left to lower left corner and zeros everywhere else is called the identity matrix. So here's a 2 by 2. So you can only have an identity matrix with a square matrix. And you can only find an inverse of a square matrix. So this week we're going to talk about square matrices and finding the determinant and inverse. So one reason we have to find the determinant is to find the inverse, you need to know the determinant. Also post a video on how to do some matrix math on a Desmos calculator. So you can always check your answer if you do it by hand. And then for the 3 by 3, the lesson this week says you don't have to do it by hand. You don't have to do a 3 by 3 inverse with pencil and paper. You can just use the calculator. So once again, the identity matrix, this is a 2 by 2 square matrix. One's on the diagonal. Here's a 3 by 3 square matrix. One's on the diagonal, zero everywhere else. That's called an identity matrix. So matrix A and B are inverse if A times B and B times A equals the identity matrix. So this first problem here says prove that A and B are inverse matrices. So if I multiply A times B, I do 3 times 1, which is 3. Negative 1 times negative 2 times 1 is negative 2. And add those together. I get a 1 there. And then 3 times 2 is 6. And negative 3 times 2 is negative 6. Add those together, I get a 0. Negative 1 times 1 and 1 times 1. Add those together, get a 0. And negative 1 times 2 is negative 2. And 1 times 3 is 3. And I get a 1 there. So remember, when you're multiplying matrices, a row times column, and row times column, and then sum the products. So once again, there's a song, row times column, multiply them line and line. Sum the products, form a matrix. Now you're doing it just fine. So you can see that A times B is equal to the identity matrix. Now we have to check B times A. So B times A would be 1, this row here times this column. So 1 times 3 is 3, and 2 times negative 1 is negative 2. And then this row times this column. 1 times negative 2 is negative 2, and 2 times 1 is positive 2. And then this row, the second row, times the first column would be 3 minus 3, right here, 0. And then this second row times the second column, 1 times negative 2, negative 2, 3 times 1 is 3. And then you sum the products, and you do end up with the identity matrix. 3 minus 2 is 1, negative 2 plus 2 is 0, 3 minus 3 is 0, negative 2 plus 3 is 1. And then for the second problem, same thing. Prove that A times B are inverse matrices. So A times B, 1 times 4 is 4, 1 times negative 3, negative 3, 1 times 1, 1 times negative 1 is negative 1, 1 times 1 is 1, 3 times 4 is 12, 4 times negative 3, negative 12, 3 times negative 1 is negative 3, 4 times 1 is 4. Sum the products, I do get the identity matrix. Now B times A, I wrote this out because it's hard for me to work backwards here. So if B is first, then I have to multiply this row times this column. So it's easier for me to write the B matrix first and then the A matrix second. So when I do A times B, they're in a correct order, and it's easier to look at it one left to right the way we read. So left to right the way we read, B matrix first and then the A matrix. So 4 times 1 is 4. Negative 1 times 3 is negative 3. 4 times 1, 4. And negative 1 times 4 is negative 4. Negative 3 times 1, negative 3. 1 times 3 is 3. Negative 3 times 1, negative 3. And 1 times 4 is 4. So when you sum these products together, once again, to get the identity, so if A times B and B times A is equal to the identity matrix, then the matrices are inverse of each other. On problem 15, or page 15, the determinant of a 2 by 2 matrix, and you're going to have to do this in the check for understanding, is find the determinant. So the determinant is this symbol right here. It looks like the absolute value symbol. That means the determinant of A, B, C, and D. And so many times in the past, when students see this, they actually do the absolute values. It doesn't mean the absolute value when you see a matrix. It means the determinant, which means take the diagonals here, A times D. So you multiply this diagonal together and you subtract this one. So A times D minus B times C, or C times B. You can change this to CB. Because I always do this, A times D minus C times B. All right, so to find the determinant of each of these 2 by 2, 1 times 4 is 4 minus 3 times 2, which is 6, and then 4 minus 6 is negative 2. This one, 1 times 3 is 3, 0 times negative 4 is 0, 3 minus 0 is 3, and then 6 times 2 is 12, minus 3 times 4, which is 12. So subtract those two, you get 0. So if A, B minus B is not equal to 0, then you have an inverse. And to find the inverse of a matrix A, you do 1 over the determinant, and then you take this diagonal and you switch positions with the entries or elements there. So D switches with A, and then these two on this diagonal, you just do the opposite. So opposite of C and opposite of B. So if I want to find the determinant of a 2 by 2, and you're supposed to have the skill to do this by hand. I'll also show you how to do it on the calculator to check your math. But this one here, 3 times negative 1 is negative 3, and then minus a negative 4 would be plus 4. So 1 over 1 is just 1. So you're multiplying each entry. This would be the scalar here. Multiplying each entry by 1. And then you want to switch these two numbers here, these two entries. So you switch them, becomes negative 1, 3. And then the opposite of negative 1 is positive 1. The opposite of 4 is negative 4. So I do 1 times all these entries here. So that none of these are going to change because this is a 1 right here. You have negative 1, negative 4, 1, and 3. In other words, if I multiply these two together in either order, and if I do this is A and this is B and I multiply them together, I get the identity matrix, or B times A would be the identity matrix if I multiply those back together. So that's one way you can check to see if you have the right answer, is multiply these together and see if you get the identity matrix. So find the inverse of a matrix if it has one, state the inverse if it does not. So this one is 6. 6 times 1 is 6. Minus 6 is 0. So the determinant is 0. So the inverse does not exist. I can't do an inverse of this matrix because I would have 1 over 0. I'd be dividing by 0. And so they call this a singular matrix when it doesn't have an inverse. So this would be a singular matrix. It does not have an inverse. All right, and find the inverse If it has one, and state the inverse, or state that the inverse does not exist. So this one does have an inverse because you have 6 minus 4. The determinant is 2. So 1 over 2. So you get 1/2. And then you're going to switch these two entries, 2 and 3. And then the opposite of 4 is -4. Opposite of 1 is -1. So you're taking the 1/2 of each of these. So 1/2 of 2 is 1. And then 1/2 of -1 is -1/2. 1/2 of -4 is -2. And 1/2 of 3 would be 3/2. So you multiply each entry by 1/2 here. That's 1 over the determinant, and you end up with this. So in other words, if I multiply these two together, I would get the identity matrix. All right, on page 16 is the determinant of 3 by 3 in the check for understanding. You're not going to have to do that, but here's the formula or way you have to find the determinant of a 3 by 3. I'm going to skip this page. You're not going to be graded on doing the determinant by 3 by 3. And you could do it on the calculator if you had to. All right, so on this page, I'm only going to show you the 2 by 2s. You can take a look at these at the bottom, 5 through 8, but I'm not, or 5 through 8, yeah, and then I'll come down here and do 9 and 10. So the determinant of this 2 by 2 is -1 times -4, 4, and then subtract 1 times 2 is 2, so 4 minus 2 is 1, or 2. And then -6 is this product, minus a -25 would be plus 25. So you get 19 for that determinant. Multiply the diagonal 12, and then this diagonal is -20, but you're subtracting it, so it becomes positive 20. So you get an 8 there. And then -10 minus 0 is -10. So we skip these middle ones, these 3 by 3s, and then down at the bottom, determine if the inverse exists. So the inverse does not exist here because you have 0 minus 0. The determinant is 0, so it doesn't exist. And then this one, the product of the diagonal is 10 minus a -10 would be, whoops, there's a mistake here. 10 minus a -10 would be 20. So this should be 20 here. Let's see if I get my pen working here. So right here, it should be 20. So inverse exists there. Because the determinant does not equal 0. All right, and then page 18, find the inverse of each of these. So I'm just going to do 11 to 14, and you could do these on the calculator here at the bottom, 15 to 18. Number 11, if this product on the diagonal is 3, and then subtract 9, so you have -1/3. Switch this diagonal, -1 and -3. Opposite of -9 is -9. Opposite of 1 is -1. So I do -1/3 times each of these entries here. So 1/3, 1/3, and -9 divided by -3 would be 3. -3 divided by -3 is 1. Number 12, the product of this diagonal is 9 and minus a 12. would be negative 1/3 again. So negative 1/3, and it's when you switch these two entries, it doesn't look like anything happened because they're the same. And then the opposite of negative 4 is positive 4. Opposite of negative 3 is positive 3. So you're doing negative 1/3 times each of these entries. Get 1, negative 1, negative 4/3, and 1. Number 13, this diagonal product is 4 minus 0. So you get 1/4. Switch these two entries, negative 1, negative 4. Opposite of negative 8 is positive 8. There's no opposite of 0, so just a 0 there. And then 1/4 of each of these, negative 1/4, 0, 2, and negative 1. Number 14, 12 minus a 2 is 10. And then switch these two. The opposite of negative 2 is positive 2. Opposite of negative 1 is positive 1. So 4/10, 1/10, 2/10, and 3/10. You can simplify a couple of those. 4/10 becomes 2/5, and 2/10 becomes 1/5. So 2/5, 1/10, 1/5, and 3/10. Right. So number 15 is just finding the determinant. You can use the calculator. The determinant doesn't equal 0. It gives you a negative 5 here. The determinant here is negative 8. So that has an inverse. And these are just from the calculator here. I did these on the calculator. I'll post another video of how to do that. I'm going to stop the video right here. And then I'm going to put it in the supplemental area.